So further we will consider, let us suppose this is ground plane above which there are conductor which is at a height, let us suppose h from the ground, and another conductor which is also height h above the ground. As we have discussed in previous lecture that this conductor is carrying positive charges and this one is carrying negative charges. We'll consider their images below the ground at the same height. Okay, suppose this is conductor 1, this is second, this is image of second, image of first. The distance between these two means conductor and image of second, it is I, and the aerial distance between these two adjacent conductor, it is, we will consider it as a. See, these are the conductors. We consider this is a line. Same way the images. And as I told you, this is ground plane. We will consider V1 is nothing but the potential difference between this conductor and ground. Okay, so this is nothing but the particular transmission line in practice above the ground plane, and its effect is taken into account by placing its images below the ground. So as I told you, the charges on this conductor, it will be, let us suppose this is Q1 and Q2. These are the charges present or on that conductor, and their negative charges means this is conductor which is carrying positive charges, the images will carry negative charges. So their potential with respect to ground means the conductor 1 is having potential with respect to ground is V1, and conductor 2 is having a potential with respect to ground is V2. And you know that the potential difference V is equal to Q upon 2 pi epsilon 0 epsilon r ln of 2h upon rho. So let us say the charges on aerial conductor are Q1 and Q2. It is in coulombs per meter, and their potential with respect to ground are V1 and V2 as shown in figure. So this potential, the equation for this potential, V1 is equal to Q1 upon 2 pi epsilon 0 epsilon r ln of C here. V1 means at this conductor the potential it is due to its own as well as image plus the charges Q2. ठीक आहे, म्हणजे Q1 मुळे असणारं पोटेन्शियल प्लस Q2 मुळे. तर Q1 मुळे असलेलं काय असेल, you know that what is formula for potential. In previous lecture we have derived the formula. I will show it to you. See, phi is equal to Q upon pi epsilon 0 epsilon r ln of 2d upon rho. ओके, हे समजून घ्या. तुम्ही म्हणता सर इथे पाय अपॉन मीन्स Q अपॉन पाय epsilon 0 आणि आता आपण इक्वेशन दिलं तर 2 पाय epsilon 0 असं लिहिलं. तर या केसमध्ये म्हणजे याच्या अगोदर जे आपण इक्वेशन डिराईव्ह केलं तिथे काय होतं, हा एक कंडक्टर होता, हा एक कंडक्टर होता आणि यामधलं जे डिस्टन्स होतं ते 2D होतं. ओके, इट इज कॅरिंग चार्जेस पॉझिटिव्ह क्यू, दिस वन इज कॅरिंग चार्जेस निगेटिव्ह क्यू. सो V इज इक्वल टू Q अपॉन पाय epsilon 0 epsilon r ln ऑफ 2D अपॉन रो. आता या केसमध्ये जर आपण इथे ग्राउंड कन्सिडर केलं, ठीक आहे, so this will be V1 and that V1 will be V upon 2 which is equal to Q upon 2 pi epsilon 0 epsilon r ln of 2D upon rho. हे समजतंय का? सेम केस आपण आता पुढचं जे डेरिव्हेशन आहे तिथे पाहतोय. इथे लक्षात घ्या की आता हा एक कंडक्टर आणि इथे आणखी एक आहे विच इज ॲट अ मीन्स V2. आता इथे या पर्टिक्युलर पॉईंटला जर मला पोटेन्शियल कॅल्क्युलेट करायचं आहे तर त्या केसमध्ये हा Q1 आणि हा मायनस Q1 जर कन्सिडर केला आणि याच्यावरचे चार्जेस Q2 प्लस Q2 आणि मायनस Q2 जर कन्सिडर केले तर हे दुसरे कंडक्टर पिक्चरमध्ये आल्यामुळे इथे जे पोटेन्शियल असणार आहे ते काय असणार आहे, इट विल बी V इज इक्वल टू V1 प्लस V2. दॅट V2 इट इज ड्यू टू म्युच्युअल. ठीक आहे, म्हणजे आत्ता जे मी इक्वेशन लिहिलं V1 is equal to Q1 upon 2 pi epsilon 0. Why 2 pi? Because it is with respect to ground. In between these 2 point consider केलं तर इथं फक्त V1 upon pi epsilon 0 epsilon r आला असतं. But as it is with respect to ground, it will be Q1 upon 2 pi epsilon 0 epsilon r ln of, in this case it is, what is distance between that? Yes, these two conductor, it is 2h1 divided by rho plus due to mutual Q2 upon 2 epsilon 0 epsilon r into the distance of image which is equal to, आता हा फर्स्ट कंडक्टर आणि सेकंड, so I will denote it as a I12 upon, let us say suppose this A, it is in between 1 and 2, so it is A12. So V1 काय असेल, Q1 upon 2 pi epsilon 0 epsilon r ln of 2h upon rho. आता इथं H1 म्हणतो मी, ρ1 म्हणतो, कारण की कंडक्टरचं डायमीटर असं आपण इनिशियली कन्सिडर करूयात की डायमीटर वेगळे आहेत. इथं डायग्राममध्ये जरी मी दाखवलं असेल की हा कंडक्टर H हाईटवरच आहे, इथे पण H, पण आत्ता आपण जे इक्वेशन लिहितोय ते असं इमॅजिन करून लिहितोय की हे हा H1 वर आहे, हा H2 वर आहे, या दोघांमधलं जे डिस्टन्स आहे ते I12 आहे आणि या दोघांमधलं जे डिस्टन्स आहे ते A12 आहे. ओके, means further we are going to solve that. So right now I have written equation that this conductor is having diameter ρ1, it is at a height h1, so what will be that equation, Q1 upon 2 pi epsilon 0 epsilon r ln of 2h1 upon 2 ρ1 plus Q2 upon 2 pi epsilon 0 epsilon r I12 upon A12. आता हेच इक्वेशन मला सेकंड कंडक्टरसाठी लिहायचं असेल म्हणजे V2 साठी, तर V2 साठी काय येणार आहे, just a minute. See, आता आपण इक्वेशन लिहिलं V1चं. V1 म्हणजे काय असणार आहे, सेल्फ प्लस म्युच्युअल. सेल्फचं इक्वेशन काय आलं, Q1 अपॉन 2 pi epsilon 0 epsilon r ln of 2h1 अपॉन ρ1 प्लस म्युच्युअल काय म्हणजे दुसऱ्या कंडक्टरच्या चार्जवर मुळे असणारं पोटेन्शियल, इट विल बी Q2 अपॉन 2 pi epsilon 0 epsilon r distance of its image, means distance of conductor 1 from image of the second conductor, and that distance is I12 divided by A12. आता इथे V2 चं इक्वेशन काय आहे, V2 is equal to, I can write down, आता Q1 मुळे काय असणार आहे, म्युच्युअल असणार आहे, सो Q1 अपॉन 2 pi epsilon 0 epsilon r ln of हे जे डिस्टन्स आहे, सी या कंडक्टरवर या चार्जेसमुळे असणारं पोटेन्शियल, सो इट विल बी ln ऑफ I, instead of I12 I can write down I21 or I12 also, so I12 divided by A12 प्लस सेल्फ मुळे काय असेल, Q2 अपॉन 2 pi epsilon 0 epsilon r ln of 2h2 divided by rho 2. So these are the two voltages on that particular conductor. हेच जर इक्वेशन आपल्याला मॅट्रिक्स फॉर्म मध्ये लिहायचे असतील तर कसं लिहिणार आपण? इन मॅट्रिक्स फॉर्म this is V1, this one is V2, which is equal to ln of 2h1 divided by rho 1. ही टर्म येईल पहिल्यांदा, इथे येणार आहे सॉरी सेकंड टर्म ln of I12 upon A12 इथे कोणती टर्म येईल? दिस वन ln of I12 divided by A12 into ln of 2h2 upon rho 2 into q1 upon 2 pi epsilon 0 epsilon r and q2 upon 2 pi epsilon 0 epsilon r. So this is the representation for in matrix form, or this can also be written as, or instead of V1 V2 I can write down V, it is equal to, this is nothing but the Maxwell matrix, right? So this is P and this is charge, so Q upon 2 pi epsilon 0 epsilon r. So the element this P, where this P is nothing but the Maxwell potential coefficient. It is Maxwell okay. So in this particular equation आत्ताच आपण एक डायग्राम पाहिली की त्या डायग्राम मध्ये जर आपण कन्सिडर केलं की right now we have written the equation for h1 h2, but if we consider this h1 is equal to h2 म्हणजे ही जो horizontal configuration line असेल तर h1 is equal to h2 is equal to h, right? Both of them are having same diameter, so rho 1 is equal to rho 2 is equal to rho. Again this a12 which is equal to a21 I will consider it as a a. So for सिंगल फेज लाइन, आता जे आपण इक्वेशन बघतोय सिंगल फेज लाइन साठी बघतोय, सिंगल फेज लाइन अबाव द ग्राउंड. थ्री फेज मध्ये काय असतं की सगळेचे कंडक्टर आहेत डिफरंट हाईटवर असतात, पण सिंगल फेज साठी तसं नसतं, सिंगल फेज साठी ते हॉरिझॉन्टल असतात. सो फॉर सिंगल फेज लाइन लेट अस से सपोज V1 इज इक्वल टू V2 इज इक्वल टू V, H1 is equal to H2 is equal to H, again rho 1 which is equal to rho 2 rho, and Q1 equal to Q2, we'll consider it as a Q, and A12 is equal to A. So if we did some such type of consideration, तर या केस मध्ये काय होईल, I will redraw the diagram for this particular consideration. आपण म्हणूयात की हे ग्राउंड आहे, this is conductor 1, conductor 2, it is at a height h, this is also h, again its image below the ground which is at a height h, this is also at a height h. This distance is I12 which will be denoted as I, this is A, बरोबर आहे, 1 2 1 dash 2 dash. So what is the value of I? जर आपण triangle consider केला, so this I, this height is 2h and this one is A, so I will be 4h square plus A square, right? So for this particular configuration, I will write down the equation for voltage. So V is equal to Q upon 2 pi epsilon 0 epsilon R into ln of, what is that, 2h upon rho. So it is 2h upon rho minus ln of, yes, it will be I upon A. And what is the I? It is equal to under root 4h square plus A square divided by A. So phi is equal to Q upon 2 pi epsilon 0 epsilon R ln of, multiplication है म्हणजे डिविजन होणार आहे, and after solving this it will be 2HA divided by rho under root 4h square plus A square. It is in folds. Okay, so this is nothing but the potential. We have to calculate the capacitance. So this equation, it can give the capacitance per unit length on each conductor. So the capacitance per unit length of conductor Cg, it is denoted by Cg, which is equal to Q upon V, and here it will be Q divided by Q upon 2 pi epsilon 0 epsilon R ln of 2HA divided by rho in bracket 4h square plus A square. So what is Cg from this equation? Cg will be 2 pi epsilon 0 epsilon R divided by ln of 2HA upon rho in bracket 4h square plus A square. Now the charging current, IC, it will be 2 pi F into Cj into V, and these are the equation for charging current and charging reactive power. You have to remember it. QC, it will be 2 pi F into Cg V square. It is in VAR, and this current, it is in ampere.